up is Ayan. Now Ayan is one of our middle school students, but you would never have guessed that because of how impressive he was throughout this program and how impressive his project turned out to be. I think Ayan really takes things to the next level because I think he's truly passionate about what he did this summer. He could have really ended the project like in the first week. He had everything working in the
There
first
is no
week.
problem to solve.
Solving a problem. But back to Jan. So he finished his project in the first week, but he really wanted to learn something new. So he decided to make an app for it. And I think that really demonstrates how he was really there to learn and how he was just so excited about engineering. Never had to force him to do anything. And I think one memory that will stick out to me about Ayan is that one time that he didn't really have anything to do, and he was actually doing homework on his own willingly in the classroom. Nobody was telling him to do anything. He actually just opened up his homework. So I was like, this kid really wants to learn and really is dedicated to being just a good student and has to learn whatever he can get his hands on. So I think, without further ado, here's Ayan.
Hi, my name is Ayan and I go to Sacred Heart Schools. My project is a smart walking stick, and I chose this project because I wanted to build something that could actually help people in my community, because many people in my community who are elderly are also visually impaired. So how my project works is it mainly utilizes the ultrasonic sensor, and when the ultrasonic sensor picks up an object within the selected range, which you can change from this knob, it'll send a signal to my vibration motor, which is up here, and my buzzer, which is inside this box, and tell it to start beeping / vibrating. So for a quick demo of my project, actually before that, this is my app. I also created an app, which basically when you click this on button, turns this walking stick on by sending a number to my ESP32, which is my microcontroller that I use for this. It sends a specific number which tells it to turn the walking stick on, and when you click the off button, it sends a different number to turn the walking stick off. So for a quick demo, if you hit this on button, it'll turn the walking stick on. When an object is detected in the range, it'll beep and vibrate. And you guys can't feel the vibration since I'm holding the stick, but it actually is vibrating. You can also change the distance for which my ultrasonic sensor reads through this knob right here, and when you're done using it, you can hit the off button and it will stop functioning. From the original project, I made many different modifications. My first modification was making a feature such that when the obstacle the smart walking stick is detecting moves closer, the beeping speed increases, and when the obstacle moves farther away, the beeping speed decreases. The second modification I made was adding this knob where you can change the max distance. It is really a potentiometer, and I added this thing to make it look more like a knob which you can turn. My final modification was actually this app from which you can turn on and off and connect the smart walking stick via Bluetooth. So during this project, I faced many challenges. My biggest challenge was actually integrating Bluetooth. First, I originally had an Arduino rather than ESP32, and for those of you who don't know, an Arduino is a microcontroller. I originally had an Arduino, and to get Bluetooth integrated, I connected a HC05 Bluetooth module, but that wouldn't connect to my iPhone, so then I had to replace that HC05 Bluetooth module and my Arduino with the ESP32, which is the microcontroller I'm using right now, but that still didn't work. So as a last resort, we had to order an Android phone, which is this phone right here. So I also faced one other challenge, was that my measuring skills were horrible. It took me 6 tries just to 3D print 2 components correctly in the correct size. So for my next steps, I plan to make my app even better by adding a feature where you can change the max distance for which my ultrasonic sensor reads. From Blue Stamp, I learned a lot of things. I learned how an ultrasonic sensor works, how a vibration motor works, how a potentiometer works, and how a buzzer works. I also learned what all the pins on an Arduino and all the pins on an ESP32 are used for. Thank you. Does anyone calipers on tightly, so the millimeters got like did I got the wrong measurements for yeah.
You mentioned that your ultrasonic can detect the object distance and the sound will be different.
I can't hear you.
So you're saying your smart walking stick can detect the object distance
Yeah.
versus the sound, how loud it is. How far can you detect that?
So this ultrasonic sensor can detect up to 340 centimeters.
Oh.
What was the most challenging thing about building this app that you did?
Originally, I mean, building the app that I have now wasn't that challenging, but originally I tried to add voice recognition, so that you could speak to the app, but that was really hard, so that was probably the most challenging part. It's not in my app right now, but I plan to add that later.
How does your code understand how much the knob is turned?
It basically finds the average of the resistance between these two, because a potentiometer is like two resistors, and it basically finds the average between them from numbers 0 to 1023.
Very cool.